Let's examine understanding and interpreting linear functions and graphs. We're going to look at what it means to have dependent and independent variables. We'll also look at understanding what intercepts mean, slope, and in this case we're going to focus on slope as rate of change, and then we'll look at interpreting some information from the graph. And so your independent variable is that variable that represents the quantity that is being manipulated in the experiment. So this is usually your x-axis. So let's give some examples. So if I have a graph, let's look at that. And we're looking at time traveled, and then we're looking at the distance. Okay, and here, what we're manipulating right here is the time, because the further the time is traveled, or the further the time you spend traveling, the greater your distance. So your time becomes your independent variable, because when this changes, it forces the other variable to change. Now, using the same example, let's look at what a dependent variable is. A dependent variable is one whose value depends on the independent variable. So what this means is that the dependent variable changes only when the independent variable changes. So here, the dependent variable is what we're measuring. So for example, if I use the same example I had earlier, we have time spent traveling, and then we have distance traveled. Now, when the time spent, so if I have a graph that looks like this, for example, when the time increases, your distance also increases. So for as long as we have this graph here, we see that as we spend more time traveling, we expect to travel more of a greater distance. And this is usually the y-axis in the graph. And also, if you're trying to create an equation for it, the dependent variable becomes your f of x. So if I had a graph, if I had a function f of x equal to 2x plus 3, for example, this f of x is your dependent, and then this x right here is your independent, because you can see that as this x increases or decreases, it affects the value of f of x. Now our intercept, let's look at the x-intercept for example. The x-intercept is the value of the independent variable when the dependent variable is 0, and your y-intercept is the value of the dependent variable when the independent variable is 0. So we're going to look at some examples and see how that works. Now, to look at the slope, we're going to focus on slope as a rate of change, and the rate of change is always going to be the rate of the change in the dependent variable divided by the change in the independent variable. We can also write it a different way. Slope is change in y divided by change in x. So that's another way to look at this. So we have an example here, and we're going to apply this, what we've studied so far, to this example. So the graph shows the cost of renting boats at a fishing lake. The lake requires all customers to pay a daily usage fee for boat rentals. Now, first question is, what is the hourly rate of renting a boat? So the hourly rate is the rate of change. So let's pick, we're going to pick this right here. So 4, and let's circle that. We're going to pick 4, and we're going to pick 2. Okay, so the rate of change is the change in Y divided by the change in X. So our change in Y is 145 minus 95 divided by change in X is 4 minus 2. So this is 50 over 2, which is 25. So that means that we have $25 over 1 hour. Okay, so what is the hourly rate of renting a boat? It means we pay $25 per hour for boat rentals. Okay, now generate a function R of B, the cost of renting a boat. So generally, your function is going to be in this format: f of x equal to mx plus b, where b is your y-intercept. We can see right here that b right here is going to be 45. So the cost of renting a boat is going to be, your slope is 25, b plus your intercept is 45. So your slope is 25b plus your intercept, which is 45, and you're given that value right here. Now we have the same graph. What is the fixed rate of renting the boat? So the fixed rate of renting the boat, you always have to look at it this way, is the amount you pay when you haven't spent any time using the product or using the boat. So here you look at your time right here. This is going to be your y-intercept, or your dependent variable intercept. So at this point here, the number of hours spent is 0. So you haven't really rented the boat, or you haven't spent any time on the boat, but you have a payment of $45 due. So that's going to be your fixed rate. So fixed rate is $45 because it is cost when time spent is equal to 0. How much will it cost to rent the boat for 9 hours? So we already have a function R of B is equal to 25B plus 45. Now we want to rent the boat for 9 hours. So R of 9 is equal to 25 times 9 plus 45. 25 times 9 is 225. Let's show it here. 25 times 9. 5 times 9 is 45. You write a 5, carry up a 4. 2 times 9 is 18 plus 4. That's 22. So 225 plus 45. So 225, 45. We add that together. Put a 0 here. 5 plus 5 is 10. You write 0, carry 1. 2 plus 1, 3 plus 4 is 7. 2 plus 0 is 2. So this is 270. So this is going to give us $270 as the cost of renting that same boat for 9 hours.